So here's practical two examples of expansion, binomial expansion, using Pascal's triangle. The first thing, I'm just going to generate Pascal's triangle on the side so that we can have it for use. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, first we're going to start with the coefficients. Because this is x plus 4 to the fourth, we're going to go to the fourth row of Pascal's triangle. Remember, it starts at row 0, so you go 0, 1, 2, 3, 4. And all I'm going to do is write the coefficients. I'm leaving them a whole bunch of room in between those because we're going to fill them in with other terms. Next thing I'm going to do is take my x. Our first variable, or our first term, is going to start at x to whatever the nth power is. In this case it's 4. And it's going to work its way down to 1. Actually down to 0. So x cubed, x squared, x to the first, x to the 0. The next is we're going to take the start with the 4 and repeat the process, but now we're going to start at 0. 4 to the 0, 4 to the 1, 4 squared, 4 cubed, 4 to the fourth. What's kind of nice, if you add the exponents in any term, it should always come out to the same number. In this case, whatever your k is. 4 and 0, 3 and 1, 2 and 2. Those always are adding up to 4. It's a nice little check so you know if your exponents don't ever add up to 4, you've kind of messed up somewhere along the way. At this point, all we're going to do is expand. We're going to combine like terms, multiply things out. 1 times x to the fourth, 4 to the 0 is 1, so we're just left with 1 times x to the fourth, which is x to the fourth, plus 4 times 4 to the first is 4, gives us 16, x cubed, plus 4 squared 16, 16 times 6 gives us 96, x squared, plus 4 cubed times 4, that's the same thing as 4 to the 4, which is 256x, plus x to 0 goes away, it's 1. 1 times 4 to the fourth gives us 256. Kind of wrote it over a long while, but our final answer is x to the fourth plus 16x cubed, plus 96x squared, plus 256x plus 256. For the next one, again, 2a minus 3. Now, this minus is going to help it. If we write it as plus and negative, it's going to help us with this problem. We're going to grab the coefficients once again. 1, this time from row 5, plus 5, plus 10, plus 10, plus 5, plus 1. We're going to start with 2a. 2a to the fifth, 2a to the fourth, 2a to the third. Notice how the exponents are going down each time. 2a squared, 2a to the first, 2a to the 0. Start with negative 3 now in this case. Negative 3 to the 0, negative 3 to the first, negative 3 squared, negative 3 cubed, negative 3 to the fourth, and negative 3 to the fifth. Start multiplying our terms out. 1 times 2 to the fifth, a to the fifth is 32, a to the fifth, negative 3 to the 0 is still 1, so we don't have to worry about it. In this case, we have a negative to the first to an even power, or excuse me, to an odd power, which makes this whole term negative. 2 to the fourth is 2, 4, 8, 16 times 5 times 3 gives us 240, a to the fourth. Now it's a negative square, which makes this back to a positive, plus 9 times 8 times 80 gives us, or times 10 gives us 720, a cubed. Back to a minus now because it's a negative number to an odd degree, or excuse me, to an odd power, which gives us negative 540a squared, plus, following the same process, 810a minus 243.